In this lecture, you're going to learn how authentication and authorization works in Kubernetes, how you can configure users, groups, and their permissions in the cluster. And you will learn about role-based access control or RBAC concept and which Kubernetes resources we use to define permissions in the cluster. So let's start by understanding why do we need to manage permissions in the Kubernetes cluster in the first place. You have a Kubernetes cluster that Kubernetes admins are administering and developer teams are deploying resources into. Now, how do you manage permissions for the cluster? Because administrators need different access than developers, right? Developers should be limited to what they can do in the cluster so that they don't break stuff accidentally, while admins should be able to administer the cluster. In security best practices, we have the least privilege rule, which means we give every user only the permissions they need, not more. So let's start with developers. Let's say you have multiple namespaces in the cluster, and each developer team deploys their application in the different namespace. How do you make sure each team gets access to only their namespace and the resources in that namespace, so they don't accidentally break something in the namespaces of other teams? For this, we have what's called RBAC in Kubernetes, RBAC, which stands for Role-Based Access Control. So let's see how that works. With RBAC, you can define access to each namespace using roles. So role is bound to a specific namespace and defines what resources in that namespace you can access, where resource is a pod, deployment, service, secret, etc., and what you can do with these resources, like list, read these resources, edit, delete, etc. So for each developer team, you can create a role for their specific namespace that they are managing and define what they can do inside that namespace. Maybe they can only create stuff, but they cannot delete any resources. But role only defines the resources and the access permission to those resources. It doesn't include information about who gets that access defined in the role. So how do we attach role definition to a developer team? For that, we have another component in Kubernetes called role binding, which is a very simple concept. Basically, with role binding, we simply link a role to a user or user group. So we can create users and bind the role to each user using role binding. But if you have 10 developers in a team that all need the same permission, you can instead create dev team group with all the users and then bind the role to that group, instead of binding that to each user separately. And with role binding, all the members in this group will get the permission in the cluster to do whatever is defined in the role. Now, what about administrators? Kubernetes administrators obviously are the ones that are administering the cluster. They are managing all the namespaces, configuring the volumes for the developer teams that are available cluster-wide, etc. So they are doing cluster-wide operations. So how do we define their permissions in Kubernetes? Role doesn't work here because role is limited to a namespace, and admins, as we just said, need cluster-wide access. Well, for that, we have another component from RBAC, which is cluster role. Cluster role defines what resources have what permissions, but cluster-wide instead of limited to a specific namespace. So for the admins, we would create a cluster role, an admin group, and then attach the cluster role to the admin group using a cluster role binding. Now, there is one important question here, which is how do we create users or groups in Kubernetes that we can then assign role or cluster role to? Well, Kubernetes itself doesn't actually provide any resources or a specific way of creating and managing users and groups. It just gives us an interface and flexibility to do it in many different ways. So basically, user or user group concept or resource in Kubernetes doesn't exist. So it relies on external sources for creating and managing users and groups. And this external source could be a static file with user details, username, and token. It could also be certificates that are signed by Kubernetes itself, or a third-party identity service like LDAP, for example. So a Kubernetes administrator will usually configure one of these external sources, like a static file or certificate or third-party identity service in the cluster, so that Kubernetes has access to this information. And then API server, which is one of the control plane components of Kubernetes, and which is the one handling authentication of all the requests coming in Kubernetes cluster, will try to authenticate any user that is trying to connect to the cluster using one of these configured sources. So these are examples of token files for defining users. You can pass these files to API server so that API server knows where to look up the user information to authenticate users when they try to connect to the cluster. If you want to define groups that users belong to, you can simply add a group column in this users file, in this static file, and this will give you users and groups in the cluster. For certificates, you as an admin will have to manually create certificates for different users in your team. This will be the users that will be allowed to connect to the cluster. Or, as I said, as a Kubernetes admin, you will have to configure LDAP as an authentication source for the API server. So, as I mentioned at the beginning, Kubernetes allows you to configure these external sources for authentication, but it doesn't manage them itself. You have to manage them yourself as a Kubernetes administrator. Great. So we gave our admins privilege to administer the cluster using cluster role and limited permissions to our developer teams so that each can manage only their namespace and resources inside using roles. So these human user permissions are taken care of. Now, what about application users? Not only people have access to the cluster, applications and services also access the cluster. These applications can be internal, inside the cluster, or outside the cluster. For example, inside the cluster, we may have a monitoring application like Prometheus that needs access to all other applications to collect metrics from them. And we also may have microservices applications that only need resources and access to resources within their specific namespace. These applications are running inside the cluster and are talking to other applications or using other resources in the cluster. And we also have the external applications. For example, a CI/CD tool that deploys applications to the cluster, or maybe a Terraform application that configures the cluster itself. As I said at the beginning, with the least privileges security practice, we want to make sure that application only has permissions that it needs in the cluster and not more. So how do we define permissions for application users in Kubernetes cluster? For that, we actually have a Kubernetes resource that represents an application user. And this Kubernetes component is called service account. So instead of user or a group for human users, you create a service component for the application user. So your application, like metrics server, Prometheus, or external CI/CD tool like Jenkins, will get a service account component inside the cluster as a representation of that application's user. And the same way as for human users, you can link service account to a role or cluster role with role binding or cluster role binding component. And with binding, service account or the application user that is behind that service account will get permissions that are defined in the role or cluster role. Now let's see what the Kubernetes configuration files actually look like for all these components. First of all, this is an example of a role configuration file where we define what resources have what kind of access. So in each role, we have 3 sections. API group, the default one is the core API group. So when using the core API group, you can leave it empty. For others, we have to specify. Then within that API group, we have resources like pod, deployment, etc., which are part of the defined API group. And then we have as a third part, access verbs like list, create, delete, update, etc., that applies to the resources in the defined API group. This role is for a default namespace, but if you want to give access to the defined resources for namespace myApp, you will add a namespace myApp in the metadata of role. That's how you can scope the role to a specific namespace. You can also set access to resources even more granularly. For example, instead of giving access to all the pods in that namespace, you can define access to only certain pods in that namespace using resource name attribute. For example, if in the same namespace you have your own application and maybe a database, and you want to basically define separate roles in the same namespace, but for your own application and for database, basically separately as different roles, you can target these specific pods or applications using the resource name attribute, and then define different privileges on those resources. And then you have a role binding for that role to then attach it to a user, group, or a service account. Here you define a cluster role for node, which is a cluster-wide resource. So you can basically define for the Kubernetes administrators what privileges they have on worker nodes, right? Or you can also define cluster role for namespace management, since namespace is also a cluster-wide resource. But in addition to defining permissions for cluster-wide resources in cluster role, you can also define cluster role for namespaced resources like pods, services, deployments, etc., just like in the role. And if you define a cluster role with pod access, it will mean access to pods in all namespaces, not just one specific one as in the role. And in cluster role binding, you will then link that cluster role again to a user, group, or a service account. And since are defined as Kubernetes manifest files, you can create these components in Kubernetes cluster just like you create any other components like pods, services, config maps, etc. And you can also view them using kubectl, get, or describe commands. Another interesting and useful thing is that you can actually check the privileges that your current user has using kubectl auth command. If you're an admin, you can also check access or privileges of any other users in the cluster to see who has what permissions in any namespace. And this could be a very useful and convenient way to look up permissions that you have basically given to different users inside your cluster. So to wrap this whole thing up in Kubernetes security, we have 2 different levels. For example, Jenkins sends a request to the API server that it wants to create a new service in a default namespace. On the first level, API server will authenticate the user, human or application user, in this case Jenkins, in the cluster to see whether this application, Jenkins, is allowed to connect to the cluster. Can this user access the cluster at all? Does it have access credentials like username, password, or certificate to talk to the cluster? If authenticated as the second step, Kubernetes will check the authorization of that authenticated user using RBAC. So we check what role or cluster role that user has, and based on that permission defined there, does user have permission to perform this specific task that it's trying to perform? So that's how authentication and authorization in Kubernetes looks like, and how Kubernetes uses RBAC and its components to manage authorization of who is allowed to do what inside the cluster.